So we've already done I think if I'm not wrong, I've done calculus. We've started the calculus of residues, and we found how to find the different these things. Like we've already saw how to find the residues for different cases. Okay. So yesterday I was doing some case. I think this was if your function fz can be expressed as I think quotient of two functions, two analytic functions rather, and fz is non-analytic at, this was the last case that I was doing, non-analytic at z equal to z naught. Then how to find the residue of the particular function? Understand my point that gz and hz are both analytic at z equal to z naught. Okay. And further two conditions are there, that g dash z naught should not be equal to 0 and h dash z naught should not be equal to 0. Okay. In fact, you'll find that if fz is analytic at z equal to z naught, there can be a possibility that function hz is 0. Having a 0 is not a problem. So h is an analytic function, but having a function at z equal to z naught for h will create problems for f. Sorry. So I would say that if your function fz is analytic, is having a simple pole at z equal to z naught, and fz can be expressed as gz upon hz, in this particular scenario where your function fz can be expressed as quotient of two analytic function, how to find the singularity, provided z equal to z naught right now is nothing but it is equals to what? It is nothing but it is a simple pole. So for simple pole we are writing a formula. We can write formula for higher order poles also, but that will be too difficult for you to remember. If at all there is a need, I would do that. But overall, I'm just deriving a formula for the case if fz has a simple pole and fz can be expressed as quotient of two analytic function. Okay. So what you would do is, since hz is an analytic function, so what you can do, you can express it in terms of Taylor series. So I'm expressing it in terms of Taylor series. Okay. So, and if you have a pole, simple pole at z equal to z naught, then how would you find the residue? You simply multiply with z minus z naught fz and find a limit. So eventually you're left with z minus z naught, limiting value z tends to z naught. And this is, I think, gz upon hz, you can write hz naught plus h dash z naught into z minus z naught. Then you have some higher order terms in z minus z naught whole square divided by 2 factorial, divided by 2 factorial, h double dash z naught, and so on and so forth. I'm not interested there. Because see, z minus z naught in any case would cancel this, and there will be some z minus z naught terms. So here, there will be some terms in z minus z naught. So all these terms will go towards 0 as z tends to z naught. hz naught is already 0. I don't need to bother here. Z minus Z naught and Z minus Z naught gets cancelled. So what you are left with, so in such cases, the residue would be given by, alternatively, residue can be found as limit Z tends to Z naught gz upon hz at dash z, because here it is at dash z naught. No? So residue is formula becomes this. Only for the cases where your fz has a simple pole and fz can be expressed as quotient of two analytic function, I'm saying. Are you getting my point?
Yes, sir.
Okay. I can derive the same formula for other things also, but that formula you will not be able to remember. So therefore, I'm leaving it. So I'm not doing there. I'm just trying to do a few problems, and we'll. So yesterday we were discussing a few problems. So if I'm telling you find this integration for me. Integration over mod z equals to, I think yesterday I was giving you something like, mod z equal to 1, mod z equal to, let's say, 4, and I'm telling you find integration z dz upon z minus 1 into z square plus 9. So let's say this is your question and we have to do this question. Okay. So how to do this question? Okay, so clearly you can see the first thing that you have to see is you have to see the singularities. So z equal to 1, z equal to plus minus 3 iota are clearly the singularities of z upon z minus 1 and this thing. So these are simple poles. Okay, and you know then if there are simple poles, you can simply find the residue by the simple formula z tends to 1, z minus 1 into z upon z minus 1 into z square plus 9. This gets cancelled. You remain with 1 upon 10. You have to find limiting value z tends to 3 iota. This will be equal to z minus 3 iota into z upon z minus 1 into z minus 3 iota into z plus 3 iota. This gets cancelled and you are left with, I think, you are left with, I think 1 upon 6 iota, and there will be 3 iota divided by 3 iota minus 1. So this is 2. So you're getting, I think, 1 upon 2, 3 iota minus 1. And similarly, limit z tends to minus 3 iota, you will get z plus 3 iota into z upon so you will get minus 3 iota upon minus 6 iota. I think this is z minus 1, my mistake. So minus 3 iota minus 1. So you'll get this. This is again 1 upon 2 and 1 upon 3 iota plus 1, and there is a negative. Just try to add all these stuff because you have to do sum of all these residues. The sum of all these residues into 2 pi iota will be the value of the integration. The sum of all these residues will be 1 by 10, 1 by 2 take common, 1 upon 3 iota minus 1, minus 1 upon 3 iota plus 1. So you will get, I think, 2 pi iota, 1 upon 10 plus 1 upon 2, 3 iota plus 1, minus 3 iota minus minus plus upon, I think this is 3 iota ka square is minus 9 and minus 1. This is 3 iota gets cancelled, 2 gets cancelled with 2. This is minus 1 upon 10. This is plus 1 upon 10. Answer would be 0. Okay, this is clear. It's easy enough to see the answer. Should we move
Yes,
ahead?
sir.
Okay, so let us move ahead and do a few more problems and try to try to strengthen this concept of calculus of residues and a simple problem that I'm giving you from the examination. Okay, there's a simple problem that came in the examination. I don't know how to make that figure. Let's see. Ek minute, just do. This is it. Yes, shapes. So here I'll get this. ये हो गया काम खत्म. Here is one. Okay, and okay. So I think in exam it was given this is a curve gamma. Okay, so integration over this closed curve gamma of what? Z e की power iota pi z upon 2 divided by, okay, and these are your points. Minus 1 is here and 1 is here. Okay, and we have to find the integration. So this was asked in, I think, I don't know, June examination somewhere in 2017.
Yes, sir.
Okay, so how to do this problem? Let us see. You can clearly see that the singularities of the function z e की power iota pi z upon 2 upon z square minus 1 are 2. एक तो z equal to 1 and एक z equal to minus 1. So let us first find the residues. Let us first find the residues. So residue about z equal to 1. And clearly in the contour, z equal to 1 and z equal to minus 1 are both there. So let us first find the residue. The limit z tends to 1, z minus 1, z into e की power iota pi z upon 2 divided by z square minus 1. So you'll get, I think, this gets cancelled. You'll get 1 upon z plus 1 into z e की power iota pi z by 2. Okay. So first find the residue. Residue will come out as, I think, 1 upon 2 e की power iota pi by 2. Fine. And what will be residue about, I think, z equal to minus 1. The residue about z equals to minus 1. And this will come out as limit z tends to 1. Z tends to minus 1, z plus 1 divided by z square minus 1 into z into e की power iota pi z upon 2. So you'll simply get, I think, minus, I think this will be equals to minus 1, and this will be cancelling. So this will be minus 2 e की power minus iota pi upon 2. Is that clear? ये चीज समझ में आई, ऊपर से चली गई. Understand my point that iota pi by 2 is 1. So this is 1 by 2. And again, there is, I think, e की power minus iota pi by 2 is, I think, minus 1. See, e की power iota pi by 2 क्या होगा? सोचो, it will be equals to cos
Yes,
pi.
sir, minus 1.
नहीं, iota भी आएगा. Cos pi by 2 plus iota sin pi by 2, right? So this will be equals to, I think, iota, and this will be equals to, I think, minus iota. Is that clear?
Minus 1.
Is that clear?
Yes, sir.
So mostly in that examination, everybody made this kind of mistake, including me. So I'm including myself also. So what I did also, I was already selected. I came from my PhD institute because I filled the form, and I made this mistake even after teaching people. So don't think that anybody cannot make mistake. Everybody can make this mistake. Problem kya hai? I wrote all these things and I added these things up and I wrote the answer as 0. And incidentally, in that examination, you will find the answer was given as 0 on the option number A. And most of the people made this kind of mistake because see here, this contour is going clockwise, anti-clockwise. Are you getting my point? If I close this entire contour, and they deliberately made only one arrow. They deliberately only made one arrow because they wanted to see that if somebody has this kind of thought process also or not. Okay, so if you see this part where your z is equal to 1 is enclosed, you can see that this is enclosed in a curve with a clockwise, anti-clockwise orientation. The singularity is lying left to it. Are you getting my point? And
Yes,
here
sir.
it was clockwise orientation. So residue to sahi nikala, but if you try to write this entire thing up, this will again be multiplied with minus 1 because the contour that encloses minus 1 lies this minus 1 lies right to it. So basically, while encircling minus 1, you can see that this has to traverse in the clockwise fashion. Are you getting my point? And this,
Yes.
so overall, the sum of residues will come out as, I think, iota. And if you multiply 2 pi iota into iota, the answer would be, I think, minus 2 pi. So this is a mistake that, and this is a very good question to just say, just tell you that you should not make mistakes. And everybody was hell-bent where this question came from. This question came from a book called as Irvin Krasik Applied Mathematics. Okay. So overall, you should not chase books because that will be a too difficult thing for you to see. If anybody who's making a paper has got access to too many books. You have access to only a single book. Okay. तुम्हें बहुत सारी किताबें नहीं पढ़नी, but again, I'm saying even I did the mistakes. Anybody can do a mistake. Not saying because I was already teaching all these things, and still I could not figure out what. This is a kind of very silly mistake. And they deliberately choose to make only one arrow. Okay. If they would have done this thing, a few people would have understood, okay. So always remember in examination, try to see what is the sense of rotation given. Okay. That may change your things up. Okay. Let us move ahead and do a few more questions. Okay. So we were doing these questions. And let us straight skip to integrals of some type, and those integrals are very important. So these are trigonometric integrals, and we were doing some discussion yesterday on that only. Unfortunately, the class ended up. So I'll start from there only. and we'll keep doing these questions. What is my idea is that from tomorrow we'll start doing some physics part also. Okay, so that things don't get so boring. So we are at first doing trigonometric integrals. So I'm doing trigonometric integrals. Trigonometric integrals, and I would write their range is from 0 to 2 pi. What sort of integrals are these? So I will do integrals of these type. That is, I will do integrals of type where you have sine theta. I was not interested in writing these types and all those things, but that will make your game easy. So that is why I'm doing it. So I'm discussing some integrals where I have sine thetas and cosine thetas, and f is some rational function. Like f is some rational function. Rational function, it is some like if I'm saying fx is a rational function, that implies I have something in numerator, I have something in denominator, and these two are nothing but some polynomials such that hx is not zero. So f is a rational function in sine thetas and cosine theta. So what will be the way ahead? Okay, so way ahead would be to express, I'll write to express sine theta or cosine theta in terms of e to the power iota theta. Okay, the first thing is, in order to write sine theta, I will write e to the power iota theta minus e to the power minus iota theta upon 2 iota. And I will write cos theta as e to the power iota theta plus e to the power minus iota theta upon 2. So I'll express sine thetas and cosine thetas in linear combination of e to the power iota theta that I know already. And I would do what? I would express d theta as, I think, dz upon iota z, that you can clearly see that if I take z is equal to e to the power iota theta, dz will become iota e to the power iota theta d theta. And I think it is fairly easy to see that this would be, I think, dz upon z. This is iota. Iota also gets here, so you will get simply d theta. So d theta can be written as dz upon iota z. And overall, you can see that your integral can be represented as some dz. And also understand, if I'm taking z is equal to e to the power iota theta, mod z will be equal to e to the power iota theta ka mod is equal to 1. So if my theta is varying from 0 to 2 pi, if my theta is varying from 0 to 2 pi, okay, so your mod z will become 1. So your mod z becomes equal to 1. Further, theta, if it moves from 0 to 2 pi, so basically what you are doing, you are closing a circle only. So if you are taking your e to the power iota theta as z, so basically you are on a circle of unit radius. So eventually, this integral would become equivalent to writing mod z equal to 1 function of, if I'm writing sine theta can be written as e to the power iota theta minus e to the power minus iota theta upon 2, comma, cos theta would become e to the power iota theta plus e to the power minus iota theta upon 2. So your function would be represented in form of some z minus z to the power minus 1 upon 2 iota, or z plus z minus 1 upon 2, depending upon whether sine theta or cosine theta is being asked. And eventually you just find what sort of singularities are here, and you just write the residues. So just try to write the residues and multiply 2 pi iota into the sum of residues. Is that clear? So this kind of approach we are going to do as we move ahead. Okay? Is that clear? Bharat, समझ में आ रहा? आसु तुम ही हो सिर्फ. So
Yes.
at least one should remain. That is my only request. At least one. As today Alpna is not here, but at least एक भी रहेगा तो this entire year I would be teaching. So this is what is my task. That at least for 9:30 till 9:30 you remain free. I mean, today there are 3 classes, but otherwise, if you're there, so you're not joined any PhD program, or you're not willing to join PhD program.
सर बाद में बात करते.
अच्छा, okay. So this is, let's say, if I'm interested in finding an integral, this is 0 to 2 pi d theta upon, I think, 1 plus a cos theta. And yesterday we started with a very difficult problem, so I'm starting with very easier one. Okay, so if this is the case, so how would you go about this question? So I told you already that instead of cos theta, just try to write cos theta. I'm writing here, एक बार के लिए मैं लिख दे रहा हूँ, बाकी फिर I'll go very fast. So I will write cos theta as e to the power iota theta plus e to the power minus iota theta divided by 2. Okay, I will write this as z. So this is z plus z minus 1 divided by 2. Okay, and this entire thing, integration 0 to 2 pi, would become mod z equal to. आर यू गेटिंग माय पॉइंट? ये चीज समझ में आती है ना? देखो, अगर तुम e की पावर आयोटा थीटा को z ले रहे हो, तो ये एंटायर एक्सप्रेशन z में कन्वर्ट होगा, तो लिमिट्स भी तो z की लगेंगी। नाउ इफ यू सी व्हाट इज लिमिट z, सो यू जस्ट टेक मॉड e की पावर आयोटा थीटा का मॉड होता है 1, so mod z equal to 1 means what? This describes a unit circle. First thing is this. Second thing is that if you are saying my theta is going from 0 to 2 pi, so basically you are doing an anti-clockwise rotation about a unit circle. So basically this is equivalent to moving anti-clockwise over the circle mod z equal to 1. And this thing I already told you that d theta would become dz upon iota z. So this is a standard thing that you can do. This will become 1 plus a. I think this will be z plus 1 upon z divided by 2. Is that clear? And overall, what you will get is integration. I think closed integration mod z equal to 1. I'm not writing anti-clockwise, that you can remember in your head. So this will become 2z on above divided by, I think this will be z square. This will be, I will write 2z. So somewhere it will be 2z. Okay, so there will be some 2z. There will be some az square, I think. If I'm not wrong, 2 will come here, 2 will go upstairs. I think az square plus 1. If I'm not wrong, just try to find, is that right? Oh, no. Oh, okay, a नहीं आया. I think a plus a भी तो है. Sorry. Is that clear? ये चीज सही आ रही है? az square plus 2z plus a dz.
Yes.
एक बार चेक करें कि इसको 2 इधर आएगा, 2 ऊपर जाएगा, and dz upon iota z also. Okay, so z gets cancelled. So this will remain as minus iota integration mod z equals to 1. If I'm not wrong, गलती नहीं होनी चाहिए कल की तरह. So 2z comes here, 2 goes upstairs. So this is iota 2 iota. ठीक है, तो minus 2 iota, and this will be dz upon, you can take a common out here, so you are having z square plus 2 upon az plus 1. Is that clear? Okay.
Yes.
Okay. So now what you can do, you can see what are the roots here. So always remember, whenever you are seeing ax square plus bx plus c, what you can do, you can take a common out and write this entire thing as x minus alpha into x minus beta. So you can factorize your quadratic equation by just taking a common out. You have to remember this, that you have to take a common out. Otherwise, there will be some mistake in scaling the function. So always remember, let's say if I have a function whatever, like इसके roots मिलते हैं मुझे alpha और beta, so I cannot straightway write this as x minus alpha into x minus beta. Just take a common out. Okay, so if you take a common out, ये बता ही देता हूँ, बचपन में पढ़ा हुआ है. If you take a common out, this will become b by ax, this will become c by a. What is c by a? It is product of roots, it is sum of roots, and things are easy for you to take from here on. So I don't think I need to explain anything beyond, but you have to take a common out. So I've taken a common out, and I'm just interested in finding what will be the roots. So what will be roots? Roots will be equals to minus 2 upon a plus minus b square minus 4ac divided by 2. So this will be equals to, I think, minus 2 upon a plus minus root over, I think 2 common ले लो वापस से बाहर, root over 1 minus a square upon a upon 2. 2 से 2 gets cancelled, and you are left with, I think, you are left with two things. One is, I think, one would be, I think, यहाँ लिख देते हैं हम लोग, -1 plus root over 1 minus a square upon a, right? अब a हो जाएगा, I think, देखो इसको ध्यान से देखिए, -1, दूसरा हो जाएगा -1 minus root over 1 minus a square upon a. Is that clear?
Yes, sir.
Okay. So now I have to see that, okay. So these two are my roots. So I'll write my two roots are, let's say this is my root z1, This is my root z2, and these two roots are of this particular function, and I would say that z1 and z2 are nothing but these are singularities. And in fact, you can clearly see that these are simple poles. They are simple poles. Because your function, this can be represented as z minus z1 into z minus z2. Is that clear? Now, what remains to be seen is what singularity, that is z1 or z2. What is inside this? What is inside the circle and what is outside the circle? Okay. So my circle is a unit radius. So I'm making again that circle. This is my circle of unit radius. That is mod z equal to 1. Okay. So what can I do? Oh, I can do only one thing. I can see what is the magnitude of z1 and what is the magnitude of z2. So let us do. This is your z2 and this is your z1. So let us first find this thing. Let us first find how does z2 behave. So where does z2 lie? एक बार इसको देखते हैं. यहाँ पे लिखते हैं. ठीक है. So where is z2? z2 क्या है? -1 minus root over 1 minus a square upon a. इसका एक बार magnitude देखें. So what will be the magnitude of z2? Will be equals to 1 plus root over 1 minus a square upon a का mod. ठीक है. एक नेगेटिव को एब्जॉर्ब करा लो, कोई दिक्कत नहीं. और इसको आसान कैसे बना सकते हैं? I can multiply above and below by 1 plus root over into 1 minus root over upon a into 1 minus root over, right? और इसका mod. ठीक है. अगर इसको देखें तो क्या आएगा? थोड़ा ध्यान से देखते हैं कहाँ गए हैं. Okay. So what I'll get is I will get something like I think this will become 1 plus तो
A
use आएगा.
square
This will become
upon
1 minus a square upon a, और ये रह जाएगा 1 minus root over 1 minus a square, right?
yes sir.
This is your z2 का mod. ओके. तो ये कैंसिल हुआ. एक a स्क्वायर रह जाएगा और एक a बचा रह जाएगा. a अपॉन 1 minus root over 1 minus of a square. ओके. यहां तक कोई दिक्कत?
No sir.
No. So what I can do is okay. So you are dividing your a by something less than 1. Okay, something less than 1. Is that clear? You are dividing your z2 by, or you can do one thing. इससे अच्छा भी एक और तरीका हो सकता था. Why did we go for this manner? I don't know. But एक काम करते हैं ना. Why are we going for this thing? इससे अच्छा एक काम करते हैं. इसको अपन expand करते हैं. I think ये हर बार दिक्कत देगा. रुको. चलो देखते हैं. Okay. So I am getting z2. I am dividing a by something greater than something less than 1. So this is something less than 1. Are you getting my point? You have you are saying that this is something less than 1. Yes or no? Denominator is something less than 1. So this
Yes sir.
z2 would be greater than mod a, because uh, since this is less than 1, this is less than 1. Are you getting my point? देखो कोई चीज less than 1 होगी तो खुद सोचो ना क्या होगा. Let's say this is 1/2. इसका वैल्यू 1/2 होता है तो ओवरऑल आपके 2 नहीं हो जाएगा. ऐसा समझो this is your
Yes sir.
x. I'm saying that a divided by x है ना, ऐसा कुछ. x is less than 1. So अगर x is less than 1 तो a by x greater than नहीं हो जाएगा. So if x is less than 1, 1 upon x greater than 1 नहीं हो जाएगा. This is what I'm trying to say. And let's say if a is positive. So if x is less than 1, 1 upon x will be greater than 1. A is positive, multiply a both sides. So this will be of this way. So z2 would be greater than mod of a. Okay, but mod of a is given less than 1. Huh? So how to think about this? यार ये बहुत easy problems होती हैं, but I don't know why I'm stuck here. Yesterday also I got stuck here. Okay, let me do again. ठीक है, तो ये तो समझ में आया. I don't think इससे हमें कुछ जज हो रहा है. I want to see whether my point z2 lies inside my unit circle or does not lie inside. This is the only thing that I want to do. एक काम करके देखें क्या. Let us this is one, or I should do something else. एक और तरीके से कर सकते हैं. देखो, if I just try to find what would be my Okay, just give me a minute. Okay. अच्छा, एक चीज समझते हैं that my Z1 into Z2 will be equals to 1. Is that so? Because product of roots will come as 1. So product of roots will come as 1. You can clearly see that product of roots come out as C by A. So
Yes,
this
sir.
will be 1. This will be equals to 1. Okay. So if product of roots come as 1, okay, and this implies what? This implies that Z1, Z2 ka mod is also equals to 1. That implies Z2 ka mod, or I can say that Z1 ka mod is equal to क्या आएगा 1 upon Z2 का mod, मानते हो? And Z2 का mod is already greater than mod A, है ना? Z2 का mod is already greater than mod A. It implies 1 upon Z2 का mod will be less than mod A, मानते हो? So Z1 का mod will be less than mod A, and mod A is less than 1. That implies Z1 का mod will be less than 1. It implies Z1 will surely lie inside the cell. समझ पा रहे हो मेरी बात?
Yes, sir.
तो Z1 will surely lie inside the unit cell. Is that clear? ठीक है.
Clear.
तो अगर मॉड जेड, क्योंकि एक्चुअली यहाँ पे वी कैन नॉट गेट एनी इन्फॉर्मेशन, देखो क्योंकि देखो मॉड Z2 इज ग्रेटर देन मॉड ए, अब मॉड ए खुद लेस देन 1 है, तो ये ऐसा तो नहीं लिख सकते ना, ये तो गलत हो जाएगा ना. सो व्हाट आई डिड वाज आई रोट दैट मॉड Z2 इज ग्रेटर देन मॉड ए एंड आई ट्राइड टू यूज दिस काइंड ऑफ थिंग. सो आई कैन क्लियरली सी दैट योर Z1 का मॉड इज इक्वल टू 1 अपॉन मॉड Z2, or 1 upon mod Z2 will be less than mod A, and mod A is less than 1. So mod Z1 will also be less than, what implies Z1 will surely lie inside unit cell. Okay. Now what about Z2? So I can write Z2 is equal to 1 upon Z1 again. वही पुराना step. ठीक है. And Z1 का mod is certainly less than 1. तो 1 upon Z1 का mod क्या हो जाएगा? सोचो. 1 upon Z1 का mod will be greater than 1. It implies what? It implies Z2 का जो mod है will be greater than 1. So clearly Z2 will lie outside the unit cell. Is that clear?
Yes.
सो ए की सिंगुलैरिटी अंदर है, तो हमें किधर पता करनी पड़ेगी रेसिड्यू? ओनली एट z इक्वल टू 1. सो ओवरऑल जो भी हमने ऊपर किया, दैट इंटीग्रेशन, दैट इज d थीटा अपॉन 1 प्लस a cos थीटा reduces to finding 2 pi iota into residue at z equals to, I think, z1. Okay, is that clear? Okay, yes or no?
Yes, sir.
And it is equals to, I will write 2 pi iota, if I'm not wrong, it was minus 2, I think, iota upon a, limit z tends to z1, 1 upon z minus z1 into z minus z2, and यहाँ पे क्या आएगा? Again z, I think, minus z. Is that clear? That gets cancelled. So after all, इन सब के बाद you are left with only one thing, that is 2 से 2 तो -4, iota से iota, iota का square, this is 4 pi upon a, this will be equals to 1 upon z1 minus z2. Is that clear? And what would be z1 minus z2? You can clearly see that if I try to find z1 minus z2, this is, यहाँ मैं लिख देता हूँ, z1 minus z2 क्या होगा? So z1 is this, z2 is this, so z1 minus z2 will be equals to, I think, uh, it will be equals to root over 1 minus a square upon a and 2 times. Is that clear? See, z1 minus z2 you can clearly see. Is that clear?
Yes, sir.
Okay, so 2 root over 1 minus. Okay, so I will write it here. So it will be equals to 4 pi upon a into 1 upon 2 root over 1 minus a square upon a, तो a ऊपर आ जाएगा, this gets cancelled, this becomes 2, so answer would be equals to 2 pi root over 1 minus of a square. Okay, so this integration, which was really difficult to see, difficult to find in, difficult to find through your standard 12th class also, is very easy when you change all these things into complex, provided mods are equal. Is that clear?
Yes, sir.
Okay, so this is one. And another thing that you can do is, let's say, what to do if your numerator is occupied by some trigonometric term. So let's say if I have this sort of integration. So question number two, if you have this sort of integration, so if you have 0 to 2 pi, you have cos 2 theta d theta divided by 5 minus 4 cos theta. Now, in this case, what you have to do is you keep this alive by writing it as some real part of 0 to 2 pi e की power iota theta d theta e की power iota 2 theta divided by 5 minus 4 e की power iota theta plus e की power minus iota theta divided by 2. Okay, in order to do this question, you have to do in this fashion. So what you will get real part of modulus of z equals to 1. Okay, so real part of modulus of z equal to 1. This is, I think, z square. If you take e की power iota theta as z, this will come out as z upon iota z. Okay, and this will come out as 5 minus 2 z plus 1 by z. Okay, so this is real part of modulus of z equals to 1. This will be equals to mod z, sorry, this will be equals to z upon iota will remain here. So here will be iota. So this will come out as 5 z minus 2 z square minus 2. Is that clear? यहाँ तक कोई गलती तो नहीं कर रहे हम लोग, नहीं तो फिर अगेन देयर इफ देयर इज अ मिस्टेक देन थिंग्स विल गो रॉन्ग फ्रॉम हियर ऑन. ओके, इज दैट क्लियर?
Clear.
गलत तो नहीं हो रहा ना, कुछ भी देखते जाना. ठीक है, सो दिस विल बी, आई थिंक, रियल पार्ट ऑफ
सर जेड
इंटीग्रेशन.
स्क्वायर आएगा ना ऊपर?
एक z से एक z कैंसिल हो जाएगा बेटा.
सर नीचे 1/z वाला z ऊपर जाएगा तो?
अच्छा, एक और है, सॉरी. ठीक है, एक z कैंसिल हुआ और एक z ऊपर गया. ठीक है, सो 1 upon iota, this will be equals to z square. You take 5 also common out, so this will be 1 upon 5 iota. This is z square minus z minus 2 by 5 z square minus 2 by 5. Is that clear?
यस सर.
कुछ गलती तो नहीं कर रहे हम लोग? करने में पता चला गलती कर दी, then things cannot be amended from here.
नहीं
Okay,
सही है सर.
okay. So what you can do, you can take, you can find what is the roots from here. So you can find what is the roots from here. Oh, why did we do this? एक काम करो, मत लो 5 common out. देखिए
यस सर,
सही, डायरेक्टली कर लेते हैं ना, बाद में अपन देखेंगे इसको, बिना मतलब टाइम वेस्ट कम करना. ठीक है, टास्क. ठीक है, डायरेक्टली करते हैं. सो साफ साफ दिख रहा है कि इसकी रूट्स यहाँ पे लिखते हैं रियल पार्ट ऑफ, अगेन फिर वो टाइम शॉर्ट पड़ेगा. रियल पार्ट ऑफ 1 upon iota, I think mod z equals to 1. This is z square upon minus 2z square plus 5z को लिखो 4z plus z और यहाँ लिखो minus 2. ठीक है, टाइप सिंपल. ठीक है, so this will come out as real part of 1 upon iota modulus of z equals to 1. This is z square upon, I think this you can write minus 2z square plus 4z और एक एक अलग लेते हैं plus z minus 2. Is it? और एक काम करो dz and then you take I think first में से क्या common out ले सकते हैं? We can take common out of 1 upon iota तो है ही, mod z equal to 1 है ही. This will be equals to z square. यहाँ से minus 2z common लो, minus 2z common लोगे तो कितना रह जाएगा z, और यहाँ पे कितना है minus 2, z minus 2 और एक आ जाएगा 1 minus 2z if I'm not wrong. So clearly you can find that there are two singularities, z equal to 2 and z equal to 1 by 2. But z equal to 2 cannot be inside the unit circle. So only one singularity needs to be seen. This is it. Just try to find what is the residue about z equal to half. That z equal to half, your singularity will be what? At z equal to half, your singularity will be limit. What will be the residue? Z tends to 1 by 2. Just try to multiply and find. And let me know what will be the answer. Okay, let me know what will be the answer. Okay, so we'll meet again. Just try to find what is the residue here.